Hello everyone, welcome to Tech with Machines. Today is our day 4 of solving data structure and algorithm problems. Our today's problem is also an array problem, but we are going to discover a new technique called two-pointer technique. So far, in our first 3 problems, we have done 2 techniques. One, we have solved an array problem which was a two-sum problem using an extra space like a hash map or a dictionary. And in the other 2 problems, we could have used a hash map or an extra space, but we used a temporary variable, a constant space, to keep on updating the interim state of our result, right? Now, in today's problem, we are given a sorted array. It's already sorted, and one fact here is that the array is not only having positive integers, it can also have negative integers, right? But it is sorted. As you can see in an input, we have an array of 5 elements, and we have first element as a negative integer, which is -4, followed by -1, and then 0, then 3, then 10, right? So it has negative integers as well. But we need to find the square of each element of the array, but then again the array should be sorted. So this becomes tricky, because if you will do the square of a negative integer, it is of course going to be a positive number and could be more than the number which it is preceding or which it is succeeding, right? Like -4, if I do a square of it, it will become 16, and whereas -1 square will become 1. So I can't keep 16 now at the first position, because 1 has to come at the first position and 16 has to go after 1. So one thing could be, and there is also one more pointer which has been added, and it's very important when a question is given to you, especially about the data structure and algorithm problems. First, you understand the problem statement carefully and validate that what could be the brute force approach, and second, you also understand what are your input parameters being given, like something which could relate you to the pattern or the technique which you're going to use. Like in this case, it's sorted, and in this case also the expected output needs to be sorted, and also it has been considered that the output array which you will use will not be considered as an extra space. So you can use another array to save the output of the squares, right? So one thing could have been that we can create the square, iterate over the array, create the square, like get the square of each element of the array, which could have been like, if in this case I just simply create the square, then it is 16, 1, 0, 9 and 100, and then I basically go ahead and sort it, right? So I will do 0, 1, 9, 16 and 100. Okay, so basically find the squares here in this step by iterating over the complete array, which means it's order of n, linear time, and then sort it. And if we use efficient sorting algorithm like a merge sort or a quick sort, the complexity has to be order of n log n. So basically overall we will have order of n log n as a time complexity, right? In this case, even though we are doing finding the squares and sorting it, we are not using basically an extra space. We could basically avoid using an extra space, and even though we have been given a benefit of that you can use an output array, we can avoid that, right? But what if we take an advantage of the benefit which has been given, and they are telling us that you can use an output array and solve it in a linear time instead, right? Instead of solving it in order of n log n, we solve it in a linear time. How can we do that? Generally, when the array is sorted, there is a very specific technique called two-pointer technique. So you basically have 2 pointers, one started at the, could be both pointers starting together, or could be one starting at the beginning of the array and the other starting at the end of the array. In this case specifically, we will start one array called left pointer at the beginning of the array. Let's call it L, and that's beginning of the array, that's 0, and a right pointer which will be at the end of the array, which in this case is the length of the array -1, and in this case length of array is 5 and the -1 is going to become 4. So which means our pointer, basically left pointer, is at -4 and our right pointer is at 10, right? So we will iterate till the both of the pointers meet each other at certain point. So they will of course meet at the mid, at somewhere at the middle, right? So what we'll do is we will first check, because we know that there are negative integers, and even though there are negative integers, if we find the square, it is going to become a positive number. So why not just check the absolute value of that integer, which is the positive value of that integer. So in this case, we will check whether the value at the L, let's call it left, that is at -4, but let's take an absolute value, so which means it's 4, and the value at the right index is 10. It's already positive, so which means 10. Now which one is basically greater? Right is greater, so which means that square is going to become 100. Why not place it at the end of the array, new array? So basically our output, which might have been, let's say initially our output was also an array of 5 elements and initialized as 0. Now after this iteration, it will become 0, 0, 0, 0, and the last position will become 100. Now in this case, our right pointer has to increment, because we are done with that particular element, right? Decrement, sorry, in this case, because it's at the end of the array, it has to come towards left, so it will decrement, so which means that right in this case it's going to become 3. So this is our first iteration, right? Now in iteration 2, our left remains 0, our right becomes 3, right? Now the element at the left is still 4 if we take the positive, and element at the right is now 3, right? Now in this case, between 4 and 3, left is basically greater, so which means at this position, right, it will be 16, and in this case our left will increment, which will become, left is going to become 1, right? Now left comes at -1 and right remains at 3. So this is our iteration 2. Now in iteration 3, we have left 1 and we have right as 3 again. So at the left now we have what? At the left we have now -1, which would mean 1, right? And at the right we have 3, so which means right is greater. So in this position we will be saving 9. Now because we are taking from right, so right is going to decrement in this case, so right is going to become 2. So next iteration, still left is not greater than right, so left remains 1, right becomes 2. Now in this case, the position at the left is still 1 and the position at the right is 0. So in this case, what will happen? Because left is where this is going to become 1, left is greater, so this is going to become 1, and left is going to be incremented, so left becomes 2. In this case now, our left is 2, our right is also 2, our left is 0, our right is also 0, so this position remains 0 because square is going to become 0, and our left basically increments in this case, which becomes 3, which basically ends the loop. Now here in this case we have the output array by just using 2 pointers, which at a certain point of time are meeting each other, and we are able to basically add to the output array to the end instead of to the beginning, right? So we can start from there because we want to get the greater element, put it in the last position, then find another element, then put it in the last position, correct? And greater element can be anywhere in the left or the right, right? So this is how we solved it by linear time complexity, and still considered an output array, not an extra space. So let's try to code it now. So whatever we just did as a dry run, I have already written the code for that. I have named the class as SquaresOfASortedArray, and I have a function called square. In that, as you can see, I have 2 pointers which are initialized to the beginning of the array and the end of the array, and I have also initialized our output array to the same length as our input array. Now also because we have to put the element in this output array, we are creating a pointer which will help us to navigate the position in the output array. So we get the left element, we are using the absolute here to get the positive value of that particular position, and we get the right element. If left considers to be greater than right or equivalent to right, we find the square of it, and then we put it in the output array and we increment the left. Otherwise we decrement the right because right is happening to be the greater element. and we always decrement the I because we are basically populating the output array from the end. And finally we return the output array. So if I run this, I'm getting actually an array of squares, and which is basically sorted. Yeah, that's it. If you like the video and if you feel that these problems are helping you, please remember to give a thumbs up. Also, please subscribe. It helps and motivates me to create more videos for you. Happy learning.